And I will prove that in my next slide. So when Sean asked me to cover blockchain in 30 minutes, I thought it was challenging, but I thought we could do better. So my promise to you is that I'm going to show you blockchain in 3 seconds. I'm going to need your help for that. So please lean back on your seat, if you may. Thank you. It's also a way for me to know who's listening. See you now. All right. Tilt your head backwards and close your eyes until you feel that little tickling in the back of your head. Do you feel that? All right. Open your eyes. You know blockchain. All right. So that was my 3-second step. So I'll try to make the best use of our next 28 minutes now and show you what we have learned, because we are using blockchain in at Finastra. And we following the law of the instrument. I guess you probably heard that when you have a hammer, everything looks like a nail. We tried blockchain in different ways that worked, more or less. And there's a couple of lessons that we got out of it. So going back to the hierarchy of needs that was mentioned earlier, when you try to achieve consensus, there are layers. And the first layer of consensus is chaos, right? So you are in a group and you want to exchange data. There's no structure, there's no network. So people have information and they cannot try to communicate on an ad hoc basis. That's chaos. Once you agree on a data format, you agree on a language, or you agree on a communication channel, you can start exchanging information. Now you're talking about the same thing, so you can start exchanging data. And you can improve that by creating a network, automating the connectivity. So now you have this communication layer, you speak the same language, you can actually reach your counterparties. And that's pretty much where we've been for the past 30, 40 years. We communicate over networks, we agree on a protocol, but we don't really have a consensus mechanism, or at least we have a disconnected consensus that is creating issues such as reconciliation. We all keep our own record of data, and when we need to agree, we go back and reconcile. Do we agree that we made that transaction? And that creates a whole overhead upkeep of data. And that's where the distributed ledgers and blockchains comes in the picture, when we can achieve and record consensus. So we have this synchronized data that we agree upon and that we record together, and we know that what I see is what you see. So there's no need to go back and make sure we agree on this. So essentially, that's the hierarchy of needs for blockchain. So the legitimate question is, do you need blockchain? And in our world, since we're working in the financial industry, blockchain makes sense a lot of times. But also, in most cases, we don't need blockchain at all. There's many use cases in the financial industry that are doing just fine without blockchain. So blockchain is not a necessity. It's a stage in a maturity level. And the first thing you need to do is figure out whether blockchain actually brings value to what you're trying to achieve. There are many models out there to figure out whether blockchain is relevant for you. My recommendation is going to be to realize if blockchain adds value and where it adds value. And that where piece is going to make more sense in a few slides. So there's no such thing as the blockchain. So it's not like the artificial superintelligence of blockchain doesn't exist. So you need to figure out which type of blockchain is relevant in your context. And it turns out that there are many very different types of blockchain out there. When you think of Bitcoin, which is like a monocurrency, monologic, mono network, like only one purpose for the blockchain, will not be suitable for any more advanced financial use cases. When you think of broadcasting the data to everybody on the network, that will not fly with financial industries. So there's many different blockchain implementations, so you need to figure out which one is really relevant to you. There are common benefits of blockchain. Typically, the peer-to-peer network infrastructure is something that works really well. We're much better off communicating directly with the counterparty as opposed to go to a central server. We're much better off not depending on the hub availability, so we have a more resilient network. Performance is better. We have cryptography. We've been obviously encrypting connection for some time now, but the cryptography is now a commodity. I mean, you can get cryptography anywhere. Everything you do is now signed by your identity, so people know that the data that's being sent is sent from you. There's a very easy way to make sure that transaction is legit. There is this concept of immutability, which is, and I'm not drilling into the details of how things work, but essentially it's a signature that's attached to the data that also has a reference to the previous version of that data, so that if something gets tampered along the way, all these signatures basically turn into red. So you know exactly when data has been tampered with. So this immutability is hardening the data, and is also a commoditized tool. So when you have a blockchain today, immutability is going to be provided to you for free. It comes with the software. And of course, encryption and storage, which is better than a regular standard database that would store the data in clear. All the blockchain storage layers today are either serialized or encrypted, so you don't really have to care about this. That's something that you get for free as well. One slide that I use to just outline the differences between cryptography blockchains, or cryptocurrency blockchains, and distributed ledgers is this one, where I'm trying to compare both by showing what they have in common and what are the key differences. A typical cryptocurrency blockchain would be Ethereum. That is a smart contract, it's flexible, you can have any type of asset running on it. A typical distributed ledger would be Hyperledger Fabric or R3 Corda, which we are using here. And basically, they have these common genes, which is the topology, peer-to-peer topology. Every identity on the network has a node. There's no central server. The data goes directly between parties. There is this notion of a transaction that once you want to record something on the ledger, parties sign the transaction, and that gets committed on the ledger. And there is this notion of cryptography. Everybody has an identity with a public and a private key. Things get signed, so you have this guarantee that people are who they say they are. But there are also some critical differences that is worth considering, depending on what you're trying to achieve. So the first key difference is the way the data is being signed. So as you probably know, the blockchain world involves a block, which means multiple transactions that gets bundled together due to the inefficiency of the signing mechanism. The way transactions are signed, we lost that slide, so there you go. So the way transactions are signed today, they are basically grouped into a block, and that block is signed by miners. This is the block of the blockchain. In the DLT world, we don't wait for multiple transactions, so there's no this notion of aggregation. Every single time we have a transaction, this is committed to the ledger. So that's the key difference. We don't have to wait before we create a block. Each block is one transaction. Second key difference is how this data is distributed. So let's say if Sean and I have a transaction, if we do it on Bitcoin, everybody in the room is going to receive a copy of that block. That's the concept behind blockchain. Everybody gets a copy of that block. It's a democracy. Everybody has access to the data. If we were in syndicated lending, which is our world, that transaction may be for hundreds of millions, $1 billion. If we start sending a copy of that block to everyone, you guys will be able to guess what's going on. Because there's only so many of these deals going on in a day. So it's very important that in the DLT world, the data is not broadcasted to all the nodes. It's actually sent to individual parties. You know exactly who the data is being sent to, and you control that. The third point is who is actually signing the transaction. In the cryptocurrency world, there is this notion of a miner, which is essentially any random guy in his garage that has enough CPU power will be able to qualify as a miner. So they'll do the work, sign the block, and they qualify as a valid miner. Which happens to be a problem in the blockchain world because there's a huge concentration of miners in China, which means that they have the decision power of tilting. So there's another one there. Work? It does. So in our world, we want to know who's signing the block. As much as we love democratic processes, we also like to know who is validating transactions. And in our world, we have renowned banks that can act as a proper notary. So we ask them to sign our transactions, and we decide who gets to sign what block. So it's a very well-controlled network where we don't rely on external third parties. We are dealing with well-known counterparties, well-known organizations, so we can decide who does what. And the fourth aspect that's critically different is the dependency on cryptocurrencies themselves. Whereas in the crypto world, in the Ethereum world, if you want a miner to sign a block for you, he or she will charge you some cryptocurrency to sign that block. Meaning, if you don't have any cryptocurrency to start with, you will not be able to get anything done. With our clients, which are typically major banks, they don't necessarily have an interest in tying cryptocurrencies into their day-to-day business, such as corporate lending. We need something that's not depending on cryptocurrencies. So that's an important aspect. And I think that the underlying thinking of this is that the cryptocurrencies objective, if cryptocurrencies are successful, eventually I think they really want to disrupt banks. They want to bypass the bank altogether. Whereas the distributed ledgers have been created to empower the banks. In other words, be flexible enough to provide them with tools to be successful. So that there is this kind of a dichotomy going on between the bank haters, which are more in the cryptocurrency world, and the bank lovers, which are more in the DLT world. So when we say blockchain, we're really talking about very different things, depending on which side of the fence you are. So in our case, our product is called Lendocom, and our use of blockchain is in syndicated lending. So I just put together this slide really quick, which represents what we're actually doing. So if you are American Airlines, you need a loan for 10 new airplanes to create a new route to wherever. You're going to go to your favorite banks. Let's say you're going to Chase, and you're applying for a loan for 1.1 billion. Chase will go back internally and talk to their buddies, which typically are other banks. So they'll reach out to, Bank of America, you name it. And eventually they'll agree on an ownership structure, because Chase doesn't want to own the entire deal. 1.1 billion is a lot of cash, so they want to split the risk with other lenders. So the bank can then go back to the borrower and say, yes, here's the money. But everything going on the right here is what is called syndicated lending. So all this mechanism of splitting the payments, making sure that when there's a change of rates, when there's any kind of event on the deal, that needs to be published. So that communication going on the right side is completely hidden from the borrower. That's like internal cooking. And that's where we intervene. And this stuff today is what generates 19 million faxes. So that it's an important part of the mess going on in syndicated lending is within the space between agents and lenders. So how do we actually deploy this, and what did we find along the way? So this is a typical bank architecture, N-tier architecture, where the data is on the leftmost side of the slide, the most protected behind several layers of firewalls. Then comes, if we go left to right, comes the application layer, which shows our processes, the bank loan servicer. Then comes the distributed ledger, and so on and so forth. And the further we go to the right, the further we're close to the public network. And that red firewall on the right is the bank firewall. So it's the most secure firewall in a bank. That's the one where if you want to get anything through, you're going to have to prove your case. Who are you? Where are you going? Who's coming to you? Where do they come from? Kind of thing. So rolling out blockchain behind this red firewall has been a major challenge. In fact, even the way it's implemented today kind of defeats the purpose, because that red firewall basically means every time you get a connection configured, they have to figure out a static route. Who is coming from where, going to my ledger. And the nature of peer-to-peer is to say, well, once I'm listening, I want everybody in the world to be able to connect to me and transact with me. So now we're saying, well, you may be able to, but first you have to prove your case with the firewall. So a realistic implementation looks more something like this, where you have all the DLT components, and here I'm representing the nodes or the circles on the right, really are the individual DLT components. These are the core nodes. You need to run that piece outside the bank firewall so that you can control your inbound policy, so that you're not subject to approvals once you had new counterparties. It gives you a much more flexible implementation, And we found that banks that were doing it that way had much more success. Because if you go the other way around, you get 6 weeks of approval to get anything done. And a new connection takes you weeks. So that's a much better way. And of course, you can go all the way and move all the architecture into the network. So this is our learning, the learning curve, because when we started doing this 2.5 years ago, we basically had a choice between two nascent technologies that were full of promises, and we all dove into the promises of blockchain, and we bathed in the buzzwords, so it was great. But the conclusion is that there's really three takeaways from this project that are generic enough so that they could be reused in other contexts. The first one is that blockchain may not be needed at all. If it turns out that you either don't have a network, or you don't have a common data model, or you don't have a common data sets, you may be able to leapfrog blockchain altogether. So the first assessment is to make sure that beyond the buzzword, there is real business value, there's real efficiencies, cost savings that will sustain the business case. The second thing that we find out, and it's actually a design mistake we made early on, is that we've been too blockchain-centric. So we love blockchain so much that we decided that it would be our backend tool, so let's go all the way, which turned out to be a huge mistake, because in some cases, for things we do, we don't need consensus, we just need to communicate. And in that case, sure, blockchain could help us for some things, but just for saying, hey, how are you, we don't care about consensus. We just need to know whether you're good or not. So if you restrict the role of blockchain to where it's actually adding value, it will simplify the deployment a lot, because then you can start to roll out projects and get some communication going on without going through the trouble of deploying everything. So just make sure that you're really using this as a component as opposed to the purpose of the project. And the third obvious finding is that as much as banks are super excited about owning the technology and owning the data, and they love to have stuff on premise because they can control everything, the reality is their connectivity settings are not compatible with the promise of a peer-to-peer network. So that promiscuous aspect of the node, accepting connection from everyone, is just something that doesn't fly in the real world. So just to be realistic, I think that you set the expectation that there's no way out of the cloud. They will try to get the thing on premise, but I think you need to be really strict on the fact that they need to have a cloud deployment. And it turns out that when they're forced to, they actually accept the idea. Cloud is not that wild anymore, even for a bank, as long as they control the operations. So these are essentially the three findings that I think are relevant. And within 30 minutes, I think that's realistically what I can convey.